Hi there, this video we're going to cover a little bit about the natural logarithm function. So we've studied a bit about this number e and what it's all about. So we know that e has some pretty amazing properties. So we're going to look at the inverse of the e to the power of x function. So let's go back a bit. So we know about logarithms and know how to convert from like index form to logarithmic form. Okay, so 10 to the power of x equals y equals 10 to the power of x. So e to the power of x, we go y equals e to the power of x, but we do the same thing. So y equals e to the power of x, we'd say x is equal to log base e of y. So e to the power of x equals y. Okay, so if you're good at converting between index statements and logarithmic statements, that will be not a problem. Now, just to sort of, as a bit of shorthand, log base e we simplify. And it's called natural logarithms, and we use ln instead of log base e, just as a little bit of a shorthand. Okay, so if y is e to the x, then we could say x is ln y, or some people say ln y. I normally say ln y. So the two main logarithms we use are logarithm with base 10 and a logarithm with base e that we call ln, or natural logarithm. Okay. So let's look at the inverse function. So we've got y equals e to the x. It's this growth function here going through 0, 1, exponential growth. The inverse is just a reflection in the line y equals x, as you see here. And that function there is, let's rearrange it. If y equals e to the x, the inverse, swap the x and y values, is x equals ln y. So ln y equals natural log of e to the x. Remember, natural log of e is just 1. Okay, so x is equal to ln y. Swap the letters, y equals ln x. There we go. So that's what this function here is in blue. Y equals ln x, the natural log of x. Another way that it is defined, and this is a neat definition, you'll see that the natural log function is actually defined using area under a curve, which is pretty cool. The natural log function is defined as the area between x and 1 of the curve 1 over x. Isn't that cool? So, if we want ln of 1, that's obviously going to be 0, because we put 1 and 1 in there. Because remember, this is telling us about the area between x and 1. So if I do the area between e and 1 of this curve, 1 over x dx, that's just ln of e, which is 1. So yeah, so this is one way of defining what the natural log function is all about. This slide here, which is on page 28 in your handout, talks a little bit about what I've been talking about. I'm just going to do a few examples. Now we know the laws of logarithm still apply for the natural log functions as they do for the other ones. So these laws that we've all seen applied to log base 10 are going to also apply here with natural log functions as well. Don't worry too much about the derivatives. This thing down the bottom here about the derivatives, we're going to cover that later. So without using a calculator, evaluate ln e squared. So if I was to do part A, I know ln of e squared is the same as 2 ln of e. Right, that number just comes down the front. Therefore, I know that natural log of e, this says, what this is really saying is log base e of e. So e to the power of something equals e, obviously that is 1. So the answer to this is 2. The answer to the whole thing is 2. For part B, ln of the square root of e is the same as ln of e to the power of a half. And again, we can call that a half ln e. Now ln e is 1, so we can say that the answer to that one there is a half. All right, I want you to go ahead and have a go at the next couple, C, D, E, and F, the next 4 on that one there. If we want to solve an equation, ln x equals 2.17. Let's do this. ln x is 2.17. We know when we're solving equations, we're really good at doing the inverse of things, right guys? The opposite. So if we've got x squared equals something, we square root. If we've got the square root of x equals 4, we would square both sides. We kind of understand those easy ones. 2x equals 6, we know that the inverse of 2 times x is divide by 2. So here we've just got to understand what's the inverse of natural log of x, and the inverse is e to the power of. That's the way we undo ln x. So this would be my next step. Okay, now notice this thing here. E and ln are inverse functions, so this left-hand side we are just left with x. E to the power of 2.17, you're going to get out your trusty calculator. E to the power of 2.17 gives me 8.76, let's say. And that's to 3 significant figures. Okay, go ahead and do part B and write your answer in. Laws of logarithms apply again here. So A, really easy, ln5 plus ln3. I think we did this last time. It's just ln15. ln24 minus ln8 is ln3. When we're subtracting, we divide. ln5 minus 1. So these ones here are no different from the other ones if we had a log sitting there. There's just no difference in the way that you do these questions. Same as this one here, writing as a single logarithm. Instead of having log, we have ln. So these ones here won't look any different from what you would do normally. I'm just going to do one here on page 38. So ln of A is 2 ln c plus 3. So I could write that as ln c squared plus 3. Okay, now how are we going to write 3? Instead of writing it as 3, I want to write it as ln. How about that? Okay, so ln e cubed is the same as 3 ln e, and that is equal to 1. So that there would be 3. So that's the way that you'd write a number just like 3 or 2, or with a base of a natural log. So ln e cubed. So the right hand side of this thing here becomes ln c squared plus ln e cubed would be ln e cubed c squared. And we're adding, we multiply. So now since we've got ln of this equals ln of this, we can get rid of the ln's and just say a equals e cubed c squared. And so that's that equation without logarithms. I just want to do it a different way. Starting from my first step, ln a is 2 ln c plus 3. I'm going to go e to the power of both sides. So my first step looks like that. Okay, I can do that. I'm doing the same thing to both sides. That's cool. E to the power of ln a is just a. Now, on the other side here, we've got e to the 2 ln c times e to the 3. Now, this is a bit tricky here. That shouldn't be plus, should it? Now, if you look at the right-hand side there, when you're multiplying two things with the same base, you add the indices. So if you look at this question kind of going backwards from there to there, you'll see that I've got that right. Okay, so this is e to the ln c squared times e cubed. And e to the ln c squared, we know e and ln are inverses of each other, therefore they cancel out, so we're just left with c squared there. So we've got c squared times e cubed. And you can see we've got the same answer as we did before. So two slightly different ways of approaching that one. Have a go at part B.